Welcome to True Projects. In this video, we are going to explain about a project titled Detection of Breast Cancer using the Machine Learning Algorithm Survey. The introduction of the project emphasized the global significance of seriousness of breast cancer, a condition affecting a considerable number of women worldwide. Key symptoms of breast cancer, such as presence of breast lumps, changes in breast shape, skin dimpling, and the occurrence of the flaky patches, are highlighted. Moreover, the project acknowledges the multiple factors that contribute to these symptoms, including the changes in diet, lack of physical activity, hormone replacement, therapy during the menopause, and family history of the breast cancer. The project's main goal is to assess the effectiveness of various machine learning algorithms in predicting the breast cancer. It will conduct a comprehensive comparison of different model types used for this purpose. This study aims to explore the data indicators used to train the machine learning model and to measure the severity of cancer using the standardized numerical scale through these trained model, thereby improving the accuracy of the disease diagnosis. The project also stresses the importance of using the appropriate dataset for model training and aim to showcase the successful application of machine learning algorithm in achieving the remarkable precise breast cancer prediction. These are the basic requirements that are needed to build this project. Software requirement: Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter or Google Colab. Hardware requirements: operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know about the flow of the project, we need to discuss all these steps. The first point is importing the libraries. In this step, various Python libraries that are necessary for implementation of this project are imported. These libraries include NumPy for numerical operation, Pandas for data manipulation, Matplotlib for data visualization, and sklearn for machine learning model. And the second one is exploring the dataset. The dataset containing the breast cancer related information is analyzed in this phase. The dataset consists of various attributes such as patient demographic, symptoms, and other relevant medical data. Exploratory data analysis is performed to understand the distribution of data, identifying the missing values, visualizing the key features, and gaining the insight into the potential correlation between the variables. And the third one is data processing. Data pre-processing is a crucial step in machine learning. It involves cleaning and transforming the dataset to make it suitable for training the model. Common data processing technique including of the handling missing values, encoding the categorical variables, and scaling the numerical features. And the fourth one is checking for outliers. Outliers are the extreme data points that differ significantly from other observations in the dataset. Identifying and dealing with outliers is essential, leads to the adversely impact the performance of the machine learning model. And the techniques are used like object score to detect and handle the outliers. And the fifth one is split the training and testing data. The dataset is divided into the two parts, the training set and the testing set. The training set is used to train the machine learning model, while the testing set is used to evaluate the performance. This separation ensures that the model ability is to generalize to the new unseen data can be accessed effectively. And the sixth one is building the models. In this step, several machine learning algorithms are implemented to predict the breast cancer. The first one is Naive-Bayes. Naive-Bayes is the probabilistic classification algorithm based on the Bayes theorem, which calculates the probability of a specific event occurring given the probability of the certain other related events. And the second one is Relevance Vector Mission. Relevance Vector Mission is a Bayesian kernel-based algorithm for binary classification and the regression task. RVM is an extension of SVM that automatically determines the relevance of each training data point and select a subset of the relevant vector for the model construction. Making it more computationally efficient than SVM, RVM is particularly useful when dealing with large data sets. it effectively handle the high-dimensional feature space and avoid the overfitting. And the third one is combined approach of naive-Bayes and relevance vector mission. This is the hybrid approach that combines the strength of both the naive-Bayes and relevance vector mission. This idea is to leverage the simplicity and speed of the naive-Bayes while benefiting from the improved performance and regularization of RVM. One possible way is to do by using the naive-Bayes to pre-select a subset of the potentially relevant features and then applying the RVM to the subset for the further refinement and classification. And the fourth one is random forest. It is an ensemble learning method that builds multiple decision trees and combine their prediction to make more accurate and robust prediction. Each tree in the forest is trained on the randomly sampled subset of the data and features. This randomness reduces overfitting and enhance the model's ability to generalize the new data. And the fifth one is MLP neural network. MLP stands for multi-layer perceptron. It is a type of feed-forward artificial neural network where information flows in one direction from input nodes through the hidden layers to the output nodes. It consists of multiple layers of interconnected neurons, and each neuron is a simple mathematical function that processes its input and passes the result to the next layer. Training on MLP involves iteratively adjusting the weights of its connection through the backpropagation, minimizing the prediction error. And the sixth one is support vector mission. It's a powerful and versatile supervised machine learning algorithm. It works by finding the hyperplane in the feature space that maximizes the margin between different classes in the case of classification or minimize the prediction error in case of the regression. And the seventh one is decision tree classification. It is an effective supervised learning algorithm. It works by recursively splitting the data into subsets based on the feature that provide the best information gain at each step. The process creates a tree-like structure where each internal node represents a decision based on a feature and each leaf node represents a class label. Decision trees are interpretable, easy to understand, and to handle both the categorical and of numerical data too. And the last one is RBF network. RBF stands for Radial Basis Function Network. It's a type of neural network that uses radial basis function as of activation function. It often uses for function approximation and classification tasks. RBF network consists of 3 layers: an input hidden and radial basis function neurons and an output layer for the classification. During the training, the network learns to adjust the center and the width of the radial basis function to fit the data. And then the seventh step is training the model. Once the machine learning algorithms are chosen, the training data is used to train these models. During the training, the algorithm learns from the input data and adjusts their internal parameters to make the accurate predictions using the internal parameters within it. And the eighth one is user gives the input. When the model is deployed for the real world use, we users of the Flask framework as a web interface that the user can input the relevant data for the specific patient and use of an input to it. And the ninth one is the given input is pre-processed for prediction. The user input data is pre-processed by the same step used during the data processing phase. This ensures that the input data is in constant and suitable format for feeding into the trained machine learning model. And the 10th one is trained model is used for prediction. The pre-processed input data is passed into the trained machine model. Each model processes the input and produces a prediction about the likelihood of the breast cancer for the given patient. And the last one is final outcome is displayed. The prediction from the different models are combined and the most accurate model prediction is selected depending upon the chosen approach. The final outcome of the breast cancer prediction is displayed to the user. This prediction indicates whether the patient is likely to have the breast cancer based on the input data and the model's training on the historical breast cancer cases. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of different files within it. The dataset folder containing of the dataset, and the logo folder containing of the images of logos that are used in this web application, and the static folder containing of images within it, and the template folder containing of the HTML document like a home, result, tumor, footer. And the app is an .py file which likely contains the information related to the front-end logic. It includes code written in Python that handles the server-side operations such as processing user requests, interacting with the database, and generating the dynamic content that to be rendered in the HTML templates. And the random forest implementation or the Python source files as of app file. And Wincon breast cancer is a dataset, is a Jupyter source file where it contains the combination of the code, graphs and output all in one place. It allows the user to write and execute the code in the individual cells, making it a popular choice for the data science. And to execute the project, first we need to copy this address of the code folder and open the Anaconda prompt. First, we need to specify the disk location. Further, our folder is present in F disk. That's why I'm changing this address location and then writing and command cd space paste the address of the code folder and click on enter button. After this, write another command of python space app.py. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues and click on enter button. After running this app.py file, the framework will host the application locally at the default address as of like this. Copy this local link provided by the framework and paste it on any web browser. I prefer to choose Chrome. Open the Chrome and paste this address and click on enter button. Here this is the home page containing of different columns within it and specifying what is what in these boxes. And what here it specifies a box what is breast cancer, who gets the breast cancer, what are the symptoms of breast cancer as of like this. And to find and analyze the patient analysis, we need to enter all these column values and then click on submit button. First, enter this value as 17.9 and enter the texture mean of 12.56 and the enter perimeter mean of 132 and enter the area mean of 1201 and enter the smoothness mean of 0.32. Enter the compactness mean of 0.234 and enter the convectivity mean of 0.3445 and enter the concave point mean of 0.342. Enter the symmetry mean of 0.234 and enter the fractal dimension mean of 0.0078 and enter the radius SC of 0.456 and enter the texture SC of 0.324 and enter the perimeter SC of 9.567 and enter the area SC of 172.34 and enter the smoothness SC of 0.44 and enter the compactness SC of 0.324 and enter the convectivity SC of 0.54. Enter the concave point SC of 0.324. Enter the symmetry SC of 0.324 and enter the fractal dimension of 0.1234 and enter the radius burst of 0.4623 and enter the texture burst of 0.67 and enter the perimeter burst of 0.45 and enter the area burst of 13.56 and entered the smoothness worst of 0.45, entered the compactness worst of 0.56, entered the convexity worst of 0.98, entered the concave point worst of 0.78, entered the symmetry worst of 0.98, and enter the fractional dimension worst of 0.87, and then click on submit button to predict whether the person is having the breast cancer and what way. Click on submit button. The cancer is predicted to be of malignant. The probability of malignant is 95% and the time taken to predict is of 0.02 seconds. In this way, we can predict the breast cancer. And the project concludes that machine learning algorithms can effectively use it for detection and prediction of the breast cancer. The project provides a comprehensive comparison of various types of models applied to anticipate the breast cancer and shows the accuracy of these models higher than of 94%. The project also highlights the importance of using a proper data set to train the model and shows that the Wincon Diagnosis breast cancer dataset is widely used for application because it has the larger number of instances which is virtually noise-free. The project suggests that the use of machine learning algorithm can help in minimizing the high number of unnecessary breast biopsies and can provide a more accurate diagnosis of the disease. Overall, the project provides the valuable insights into the use of machine learning algorithms for the detection and the prediction of the breast cancer.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.